Okay. So surface area, as you already seen that we have got, ideas about surface areas. Surface area is nothing. The area of a surface. If you have a table, the area of the table would be a surface area. If you have like Rubik's cube, the six surfaces, it has six surfaces, and area of them would be the surface area. Okay. But see, in case of a two-dimensional object, we only have one surface area. Say, for instance, a square. The only surface area it is seen, it's this one. Again, for a rectangle, the only surface area it is seen is this surface. But in case of three-dimensional objects, however, you won't find only one surface area. That is what it makes difficult for us to calculate. Say, for instance, a brick, as I said previously, a brick. What are the surfaces? See, this one here and in the bottom. So that is 2. This one here and exactly at the opposite, 4. This one here and exactly at the opposite. So that means a total of 6 surfaces are there, and surface area for all of these would have to be calculated. Okay, and then added to get the total surface area. All right. Now let's see what they have said. The surface area of a solid object is equal to the combined total of the areas of each individual surface that forms it. Okay. All right. Nets. Okay, what is a net? The net of a solid object is like a pattern or plan for its construction. Okay, all right, understand. Each surface of the object is included in its net. Therefore, the net can be used to calculate the total surface area of the object. For example, the net of a cube will have 6 squares. Okay, so that means, let me simplify it for you. Have you like so any time in your life have you like teared up a juice can, not can actually, juice packet, like you have drank the mango juice or like a drink, and then it's a paper packet and you have torn it up.
I've
Uh,
never torn up juice boxes.
okay. In case of like small light boxes, like the ones which hold
I guess so.
light, did you tear it up sometime?
I think so.
Yes, all right. So now see, if you tear it up and then like spread it in the floor, okay, the total amount of area of that particular at that particular time, that will be the surface area. Okay, and what is the net is like spreading it like this. Okay, which makes for us to calculate easily. So for instance, a 3D object is difficult for us to comprehend. Okay. But in case of net, you can easily, okay, this is a 1 square, 2 square, 3 square, 4 square, 5 square, 6 square. So like calculating the surface area for 6 square is damn easy. Okay. In case of a tetrahedron, okay, it is being difficult for us to comprehend it. But if the like diagram like this is given, okay, so there are 1, 2, 3, and 4 triangles. Okay, so it becomes really easy for us to calculate. Okay, understand my point? So this is what net is. This is not, this is for you like simplification. Okay, understand?
Yes.
Okay, all right. Okay, so now the surface area of the prism. Obviously, this is a triangle. There are two triangles, as you can easily understand. And in case of the bottom rectangle, tell me what is the dimension for the bottom rectangle?
Uh, 6 times 18, which is
6 times 8.
yes.
Which is, yes, go ahead. You can tell me. Which is,
It's like 158. No,
how
that
can
is the
it be
right.
158? 6
I
times
have
20
no
is, see, there
one
are
two
like
hundred
particular
forty
solutions to do
two
this
hundred
really quick.
two two
So,
hundred what? Yeah.
see, see, 6 times 18. Okay,
Two.
if you are familiar with the like, we were like asked to memorize what will be the values we will get by multiplying with 1 to 10 for the numbers 1. Like what is 1 times 5? We will just like say it in a like blink of an eye because we have memorized it from the like get go. Okay. Or like what is 19 times 3? We will say 57. We don't need to calculate it. We already know. Okay. Like that is a system of our curriculum. I don't know if it is good or bad. I particularly think this sort of memorization is good. Now, if you would ask me what is 6 times 18, I would say 108 because I already have memorized it. But forget about memorization. So what could be the easiest way to do it? See, 6 times 18 could be difficult for us to calculate. Okay. But is 6 times 20 difficult to calculate? Tell me.
Not no.
So what is the answer?
240.
120, right? Very easy. All right.
Yes.
And in case of 6 times 2, is it difficult to calculate? The answer is no. It is 12. Okay. Then just subtract it. Then you get 108. Obviously, you won't take this much of time because when you get accustomed to this procedure, you will be like really fast in doing this. Okay. Okay. Even I do these calculations in my brain. Okay. Whenever I am not getting the idea. Okay. So try practicing this one. This is a very important hack for doing like the simplest of multiplications. Okay.
Okay.
All right. So the like the base rectangles area could be gotten like this. And what will be the area for this rectangle? Tell
At least 7.
me. Why are you saying at least 7?
Am I wrong?
Okay, yes, at least 7. It will be greater than 7. All right. So now
Okay, it's 90 though.
90, right? But we will get two 90s, okay? Because one is here and one is
120.
at the back. Okay. All right. So there are in total there are 5 surfaces consisting of 2 triangles and 3 rectangles. Okay. So if you are able to visualize it, it's like not difficult, and it's not necessary that you have to draw this sort of diagram. If you are able to um, calculate the answer, that is okay. I think so because like it shouldn't be mandatory to draw these diagrams. Okay. Surface area formula for a cube, it's 6L squared or 6A squared. This is very easy to understand. There are 6 squares, okay, and of one square the area would be A squared. Okay. For a rectangular prism, it will be C. Okay, let me explain it to you. Rather like seeing the net diagram, it will be easy for you to understand. See, what is the area for this surface?
Height by width.
Right, which is WH, right? Okay. Okay,
Yes.
now isn't this side exactly identical to that side?
Yes.
So that will be 2 WHs. Okay. Now what is the area for this in the front? Here is the
With
area.
length by height.
Length times height, which is LH plus LH, and exactly in the opposite side we have the same thing. This is another LH. All right. And what will be the area for the rectangle at the top?
Length by width.
Length by width. Okay. All right. So that would be if I draw it with the yellow color. So this one. So LW plus LW. Okay. So eventually you will get 2 times LW times LH plus WH. Okay. So this is how you get the like surface area for a rectangular prism. But if you feel like drawing nets is easier, you can do that as well. Okay. But I think like memorizing in this way would be easier because drawing 3-dimensional shapes and then like redrawing it to a 2D surface, I don't think it's easy. It will be difficult actually. Okay. All right. Now next up, triangular prism. We have already done a math regarding that. For a cylinder, I have already showed it to you how it comes. Okay. And for a cone, what would be the surface area for a cone? Okay. First of all, we have pi r square, and in case of this one, like this surface, okay. How can I explain it to you? It's sort of okay. Let me see how they have explained it. All right, so consider that what was the term for that? Arc. It was an arc. Okay, yes. All right. So see, consider this to be an arc, right? Okay, so this is a obviously a portion of a circle. Okay, so that is 2 pi r. Okay, I mean the whole of it is not seen because already this portion is with dotted. Okay, so that would be the circumference, which is 2 pi r. Okay, the whole of it. Okay, but see, whenever we are calculating the top side or something like that, okay, that is say only the front side. Okay, if you would have gotten like a party hat, you would understand it better. However, so see, what I was saying is, in case of the circular base, that is pi r square. There is no confusion in that, right? Understand my point?
Yes.
Now, in case of this particular thing, okay, you could consider it like a triangle with circular base. Consider it like that. It is a triangle, but the base is circular. So what did we do in case of triangles? We did half times base times height, right? That is what we did. Okay, right?
Yes.
But this is a sort of carved triangle. This is a sort of carved triangle, right? So it obviously won't work like a triangle. Okay, it would work like sort of circular way. Okay, so that is why we have to transform it from pi r squared. Now, obviously, if you consider with triangle, it would be like pi. Say, consider pi to be the, I mean, what can I say, half or the like constant term, and then r. Say r is the base here. Okay, r is the base, and in case of like the circle, r also is the height. Okay, because at all sides the radius is the same, it does not change. However, in case of triangles, the height changes. Okay, so that is why I'm just I've been saying all these things. These are almost vague things, okay, just for your understanding, because I cannot show you the proof right now. Okay, so now pi
Mm.
r and then the arc. What is the arc? You could say this is s, or sometimes it's also showed with l. So that is s. Okay. So all in all, we will have pi r squared plus pi r s. So which is pi r times r plus s. Okay. All right. So one is the carved surface area and one is the circular base area. Okay. So these are the two areas which need to be taken into account. Okay. All right. Tetrahedron. Okay, tetrahedron. Oh, I've already done what to do in case of tetrahedrons. Right? So for the like triangular base, we have half times b times h. But in case of tetrahedrons, all of the four triangles are the same. So that is why they have just multiplied it with 4. Okay. All right. In the next case, square right pyramid. In case of square right pyramid, we have four triangles. So for the four triangles, the area would be 4 times half times b times h, and for the rectangular base, it would be b squared. And in case of spheres, it is 4 pi r squared.
Mm.
All right. At least we have been able to complete this part. Okay, let's see if we can complete the worked examples at least. The worked example. Get the surface area of the object shown by selecting an appropriate formula. Round your answer to, okay, so what will it be? Pi r squared times pi r 13. Okay.
Yes. Yes.
Very easy. Surface areas of composite solids, very easy. For composite solids, be careful to include only those surfaces that form the outer part of the object. For example, if a solid, okay, I was about to say that if a solid consisted of a pyramid on top of a cube, the internal surface area. See, obviously, whenever you are calculating the surface area, there is a, as you can see, there is a cube and there is a tetrahedron, not tetrahedron, square base pyramid, right? Is that correct? Is that correct?
Yes.
But whenever you are calculating the surface area of cube, this surface, like this blue base surface, will already be included. Is it correct?
Yes, it is.
Now, whenever you are calculating the area for the square base pyramid, you will neglect the square base. So you have to be careful that you don't double calculate it, otherwise you will get wrong answer. Okay, that is what they're trying to say in simpler words. Okay, understand my point?
Yes.
All right, and in this case also, you will, what you will calculate is obviously 2 pi rh, no problem, calculate 2 pi rh in case of the curved surface, but only 1 pi r square, not 2 pi r squares. Okay, because whenever you will calculate the surface area of the hemisphere, already this surface will be included. Okay, this surface will already be included. So you have to be careful about that. Okay. So half 4 pi r square, see 4 pi r square plus 2 pi r. Okay. All right. All right. So number one, you will be able to do this. Number two, you will be able to do this. Okay. You have to draw the net. Why is it necessary to draw the net? I don't understand. Okay. It's not necessary. Okay, you will just need to draw 4 triangles. Okay. It was like given previously. It will be something like this. Okay. Because a tetrahedron consists of 4 triangles. Okay. All right. And you have got the like 5. Okay, this is 5, and all the sides are same. So I mean, what you could understand from this is like the base for all cases would be the same. And height, how can you calculate the height? From the Pythagorean theorem, which would be root over 5 squared plus 5 squared. Understand my point?
Yes.
Okay, good. All right. So you have to practice them at home. Okay, otherwise it will be difficult. Calculate the surface areas of the object shown by selecting appropriate formula. Okay. I think you should be able to do this one as well because it is a square base pyramid. So for the base, it will be 25 squared. And in case of the triangles, the height is already given and you have got the base. Understand? So very easy. And for the rectangle, it's easy as well. All right. So almost similar to the previous chapter. Okay, in the previous chapter we calculated the volumes, and in the same maths are given here. You just have to calculate the area. Okay.
Yes.
So try to complete up until 8, and from 9 I will show you in the next day, inshallah. Okay. So up until 8 and the previous one that I have already shown. Okay. And when can we meet next? You are not free
Um,
first and second, so we have to meet third. Is it possible to meet third? That is Thursday.
I think so. We can do third. Yeah, okay, Thursday. 4:15 slash 12:15. Is that good with you?
Okay, 3rd October, 12:15. That's 4:15 p.m. All right, yes. Okay, Allah Hafiz for today. Right.
Love to see you soon. Oh, later. Yeah.